Okay, so we've got section 9.5, solving quadratic equations by graphing. So we were practicing graphing them before, and now we're looking for the solutions, which I hope you remember where we locate the solutions, but we'll see. Step 1, you got to write the function in y equals form. So make sure it has, and now granted, you're going to have a 0 in here because you're solving. So just make sure basically that you get everything on the other side. That's what I'm referencing when I say that. Then you're going to graph it. Then you're going to find the zeros. And remember, the zeros are the x-intercepts. So you're looking to see where the graph crosses the x-axis. Okay, so let's fire away. It's similar to what we've done. So I've got the steps lined up down here for you to follow, just like before. And this is all on the same side, so we're all set there. A is equal to 2. What's B, class? 0. There's no x term. C is a negative 2. So make sure you're careful with that. All right, so we'll do the axis symmetry first. Opposite of B over 2A equals opposite of B is 0. Over 2 times 2, it doesn't really matter because 0 over 4 is 0. X equals 0. All right, so there is my symmetry line. Vertex, 0. Substitute it in now, so and see what you get. 2 times 0 squared minus 2. That is 0 minus 2, which is a negative 2. So you can just think of that like that's y equals that. Y equals y. So now I can plot the 0, negative 2. That's the vertex. Just going to go up or down. Positive. It's going to go up. If it went down, there wouldn't be any solutions, would there? It would never touch the x-axis. So going up, we now know it's going to hit it twice. So we're going to have 2 answers here. So we need to know what the y-intercept is. Oh dear, what's the y-intercept, class? Negative 2. But wait now, that's already on the y-axis here. You're right. When the symmetry line is the y-axis, you're going to notice that you lose that kind of easier point to reflect. So instead, you have to actually pick 2 points. Oh, sorry, I'm yawning now. So we're going to do this part twice since that happened. It's not that bad though. Let's just pick 1. Let's pick 1 right here. So if you pick 1 for x, we got to figure out the y. So y is equal to 2 times 1 squared minus 2. I'm just taking that from up here. And that means y equals 1 squared is 1 times 2 is 2 minus that, and y equals 0. Yay! Guess what? I don't think we're going to have to do another point. Because when we reflect it, we get that, and those are our zeros. They fell right on the line. And since that's the goal of what we were doing, I don't need to do anything else. My solution to this is right here and right here. The zeros are 1 and negative 1. All right, let's look at the next one. It's all set up fine. Our A is 1, B is 6, and C is 10. Axis of symmetry. X equals opposite of B over 2A, which is equal to opposite of 6. Negative 6 over 2 times 1. Negative 6 over 2 equals a negative 3. So x is a negative 3. So we're going to go ahead and draw that on our line here. Negative 3, 1, 2, 3. Vertical, always vertical. And I don't know why I can't draw a straight line even with a straight edge, but that's okay. All right, so we're going to do a vertex. We already have our x. We just need to plug it into our equation up here. Y equals negative 3 squared plus 6 times negative 3 plus 10. Y equals 9 plus negative 18 plus 10. Y equals negative 9 plus 10 is 1. Negative 3, 1 is a vertex. So negative 1, 2, 3, 1. There it is, on the line like it's supposed to be. Then we need our y-intercept, and now it's going to work because our line of symmetry isn't on the y-axis, so we'll be able to do this. So where is my y-intercept? There it is. C equals 10. So I'm going to go up there now and plot that on the y-axis. Where is the y-axis? Right here. So I'm going to put 10 on there, which is right here, and reflect it. So count over to my non-straight line. 1, 2, 3. 1, 2, 3. And there it is. So when we connect it, I don't need to do even another point at this case because, again, we're trying to solve this. Solving it is seeing where it hits this. So yes, getting another point would make this slightly more accurate, the drawing, but it doesn't help. I know there's what? No solutions to this, or not solutions, there's no zeros. Well, that is solutions, but anyway, there's no zeros. It never hits the x-axis. All right, let's try one more. Uh-oh, we got this negative 3 over there. We got to scooch that over. So we're going to end up with y equals 2x to the second plus 4x. And then when I move that over, we're going to get a plus 3. A is 2, B is 4, and C is 3. So let's have at it. Axis of symmetry is opposite of B over 2A, which is opposite of 4 over 2 times 2, negative 4 over 4, negative 1. Put our axis of symmetry on our graph at negative 1. That's nice. Notice I try not to make a dot, even though I did make a dot. I try not to, and I can see again I missed the line. I'm not sure what my problem is here today. I'm slanting on every one of these. Okay, vertex. Put the negative 1 in for the x, and now I need to substitute into that equation up there. What I'm going to do, I'm going to highlight the one I'm using though, so that jumps off. Those little tricks here. So I'm going to have y equals 2 times 1 squared plus 4 times 1 plus 3. Y equals 1 squared is 1 times 2 is 2 plus 4 plus 3. Y equals 6, 9. Okay. So negative 1, 9, we have our vertex. Let me use a different color here. Negative 1, 9. Way the heck up here is my vertex. Should be on that line though. Y-intercept. Do you see it? Hope so. It's right here. 3. Go to your y-axis and put it on the 3. 1, 2, 3. Now we're going to reflect, as it says down there, over 1, over 1. Always reflecting over your axis of symmetry. And, you know, I know it's going to go down, right? So it's going to get 2 solutions, but I'm not sure where yet. So let's do a 1 and see what happens if that helps us, okay? So if we pick a 1, let's plug that in and see if that helps. Y equals 2. Oh, bummer. Really a bummer. Darn it. Did you guys see my mistake? I didn't put a negative in there. Sugar. All right, so negative 1 squared is 1 times 2 is 2. That works, but this is a negative 4. Negative 2 plus 3 is 1. Uh-oh. Now we got trouble. Okay, negative 1, 1. Let's adjust this. Negative 1, 1. Oh. Well then. I don't think I need to do any more points after all. Why? And I should have noticed this before, honestly, because this is a positive 2x, so I should have said to myself, why the heck would it go down when that's a positive? I did not ask self that question. So we have, again, no zeros. Okay. Yes, doing another point can help us get a more accurate graph there. But if we're working on what we're working on, which is solving, no zeros. No zeros. 1 and negative 1 are my zeros. Okay, so I have one more problem to go through, and it's the frog problem. Some of you might have it, some depends which class, and some don't. But it's about a frog jumping straight up from the ground. The quadratic function right there models the frog's height in feet above the ground after t seconds. So even though the frog is jumping straight up, we can still do it like a parabola, because this is going to be my time and this is my height. So let's copy that down and see what's going to happen. I need to know how long the frog is in the air. So it's starting here at nothing. It's going to jump and it's going to come down wherever it comes down. And I need to know that. How long? So if I know the axis of symmetry, then I know that this would be twice that. So let's go and figure out that axis of symmetry. A is negative 16 and B is 12. So x is equal to opposite of B over 2A. X is equal to the opposite of B over 2 times negative 16. Negative 12 over negative 32. And that reduces to what? It's positive for sure. 6 to 16. Wait, we can divide that by 4. So we're going to get 3/8. Ah, and that good old fraction. Don't worry, it's okay. No tears. So x is that first thing, right? If we were going to get to the vertex, 3/8 is my x. That's this part right here, 3/8. I don't care how high it goes. It didn't ask me that. I could figure it out by plugging 3/8 into this, and it would tell me how tall it went. But that's not what they asked in the question. They asked how long is the frog in the air. So I'm going to have another 3/8 here. And what will I do with both of those? I will simply add them. 3/8 plus 3/8, or 3/8 times 2, gives us 6/8, which is 3/4 of a what? Second. Or 0.75 seconds. Same thing. So we're done. And for those of you that want to figure it out, go ahead and figure out the height. Put in that 3/8 in for your t, and tell me what that is. All right, I'll figure it out. Sounds fun. Okay, so I'm going to go down here So f of 3/8 is equal to negative 16. If you square this, you get what? 9 over 64. Plus, if you do this, we can cross cancel. Divide by 4. Divide by 4. So I get 9 over 2. Here I can cross cancel as well. 16 goes into 64 4 times. So I get negative 9 over 4 plus 9 over 2 times by 2. Get a common denominator. And I get 9/4. So 2 1/4 what? Feet. Wow. Jump 2 1/4 feet. Hopefully I went through that kind of fast. If you saw me make a mistake, you can tell me. Okay, that was just for fun. See you next time. Bye.